Hey gang, Stat 1150, what I want to show you here is some tricks for MyMathLab for working some of the problems on, well, technically MyStatLab, but MyMathLab, it's all kind of under the same heading. What I want you to have handy is I want you to have R on your computer. So go ahead and open it up and have it ready. Because I'm going to show you how to work some of these problems from MyMathLab using R, and it makes it a lot easier than using the calculator. I'm also going to show you situations where I think the calculator is easier. I'm sorry. So again, what we're doing here, this is out of Chapter 3 of the textbook. It's called Numerical Summaries and Variation. Again, there's that word variation. You know, how much do things spread? How can we explain the consistency or even inconsistency of the measurements that we have collected in our data set. So important video because you know what I'm going to do is I am going to make many of these problems that you'll encounter on your assignment in MyStatLab a lot easier. So that is always good, makes us smile, and so on. All right, gang, being goofy. So let me get started. All right, so I want to get out of here, and if you go to okay, let's see. Actually, if you go to MyStatLab, what I've done down here is let me close this down. Is I have okay, I need to let my pop-ups happen. All right, so that'll work. Okay, but what I have down here, and I dated it ahead, so you know if you're taking this class in the fall or spring, you can see that I put this video up back in June, but I dated this ahead, so when you go up here to assignments, you're not going to see this. I figured that would just create complete total mass confusion, but nevertheless, the problems that I'm going to illustrate here, you're going to see in this assignment numerical summaries of center and variation. So I want to preview these, and I want to show you some tricks of the trade. All right, so the first question that we get into says college students and surfers Rex Robinson and Sandy Hudson collected data on the self-reported number of days surfed in a month for 30 longboard surfers and 30 shortboard surfers. Easy for you to say. Complete parts A and B below. Now, when we see this, you know, we have, for longboard, we have 18 and 10 and 20 and so on and so forth. And then shortboard, we have 7, 16, 5, and so on. And I guess we have, well, we have quite a few numbers. Now, one thing that you could do here, let me exit this, and I want to get this up where you can see it, is we could come in on our calculator, and we could go to Stat, and we could go to Edit, and we could come up and clear out just the numbers. To do that, remember, we go Clear, Enter. So that clears out the numbers, but it doesn't delete the list. Now, let me show you what will happen, because this happens quite a bit, actually, from time to time. Let's say you forget that, and you go up, well, my screen has gone insane. Let's see if we can make that stop. Well, that was extremely interesting. Okay. It just felt the need to flutter. All right, so let's say we come up to L1 and we make a mistake and hit delete. Well, see what will happen is your calculator will take you literally. It will delete the numbers, it'll delete the list, the whole 9 yards. So what I'd like to do is I'd like to correct that mistake, and I'd like to go back in to the left of L2 and insert L1 that I just accidentally deleted. Now guys, if you come down on your calculator, you'll see a command right there, it said INS. Well, that stands for insert. It's blue, which tells me I have to hit this first. Now what I want to insert there is L1, which you can see right down here above the 1 key. Also in blue letters, you can see L1. So again, it tells me I have to hit the blue key first, and L1, hit enter, and it restores the list. Now, if I had numbers there, it would not only restore the list, but it would restore the numbers in the list. But, you know, again, L2, let's say I go over, I get sloppy. Daggone it, I got rid of L2, I didn't aim to do that. Go to the spot where you want to insert it. Second function, insert. I want to insert L2, hit enter. And it brings the list back, and it brings back the numbers that I deleted. So, gang, if you got a string of 40, 50 numbers that you sit there very patiently, diligently, and for right around an hour and typed in, you don't want to lose those, and you won't. But let's say I do want to get rid of the numbers. Keep the list, get rid of the numbers. Clear, enter. Delete will take you literally. So gang, back over here, if I look at the longboard numbers, I have 18 and 10 and 20, and I could sit there and type all those in. And I'll tell you what I want to do. I want to type in the first maybe 10 just to illustrate something. But for me, that's just too many numbers to sit there and type. I don't want to do that. Okay, so I'm going to type a few in that list, and I'm going to type a few over here in this list just for illustration. And if I'm making a mistake, I really don't care, because when I come to work the problem, I'm going to do it a different way. Okay, so I've got some numbers there. Now, the very first question it says is compute the means for both longboards and shortboards. Well, I would have put all the longboards in L1, all the shortboards in L2. So I would just go stat, calc, one variable stats, L1, and I would get the mean and the standard deviation for the longboards. To do the shortboards, I would do the same thing, one variable stats. I would put in L2, and I would get the mean and the standard deviation again. Guys, that's fine and dandy. I mean, it really is. If you're not impatient like me, and you don't mind typing all of those numbers in your calculator, this works fine. But if you're like me, and not like me, but guys, I can tell you, typically the students who get back in touch with me after taking my class, who have either gone on to graduate school, or they're in maybe in occupational therapy or physical therapy, they're applying for a grant. The grant requires them to do some sort of quantitative study. And I get these emails. I get about 2 or 3 every year. It seems like, Dr. Darbro, I wish I'd paid more attention in your stats class. I didn't think I'd ever use that stuff. And it turns out that they do, just as I told them they would. But yeah, it's just the way it is. But anyway, my point is, if you're really going to do stats, you're probably not going to do it on your calculator. You're probably going to do it on some technology like R, SPSS, Minitab, Jump, something of that nature. So because of that, what I want to do is I want to illustrate how I can make your life easier on this problem. Now, on my math lab, if I go to this point right here, I can see that I have my full data set, and I can click that, and it will open it in StatCrunch, which is fine. It can copy it to clipboard, or it can open it in Excel. Now, I want to open it in Excel because if I get it in Excel, transfer it into .cvs format, I can work problems in R like I've demonstrated previously. Plus, you're going to have some assignments coming up. They're going to require you to do that. So let's go through that. Let's open up in Excel, and you can see down here at the bottom, it's given it some wacky names. So I want to open that up. All right. Now, I'll tell you what. Let me get this. View it a little larger. Okay, there we go. Now, what's going on there is we have a legitimate data set, sort of. But guys, remember back from one of our first videos in week 1, a legitimate data set has information on each row pertaining to one case. Well, that's not happening here. I've got this 20 and this 5 on the same row, but they aren't related. So what I would want to do here is I'd want to come over here, and I can see that I've got something with this line right here. I don't know if that's going to bother me or not. So what I want to do is I want to come over here and copy these numbers. And I want to come over here someplace and I want to paste those. Now all of those are going to be longboard. So I'm going to type long, and then I want to fill all the way down. Okay? Now if you're like me, that not being centered would annoy the crap out of you, and it does me. Now the next thing I want to do is I want to come in and get the shortboards. I want to paste those below. And I want those to be short, because they are. Now gang, I'm getting a data set. I'm getting a data set I can work with. I don't need this stuff over here anymore, so I'm going to get rid of it. And I don't need this anymore, so I'm going to get rid of it. Now this is going to be, forget the variables exactly, but let's just call that the number of days. I believe that's right. And then my variable name is going to be I'm going to just put board type. So I'm just going to put type. Now guys, notice, let me do that, get it all centered, pretty and everything. I've got it now in a typical data set format. From left to right, I have 18 days is associated with the long type of board. So when I read on a line, I've got information that is relevant to one another, that is paired with one another. When I read up and down, I have my variables. Guys, that's the way a data set should look. It's one of the toughest things for my graduate students and students I work with on their PhDs is to not want to just put all the information in columns. Well, guys, that's not a legitimate data set in most situations. We want to read left to right, and the information we have on each line is from the same subject or from the same board in this case. Okay, so I'm going to come in now. I'm going to save this and just save as. You guys remember, I need to save this. I'm just going to be I call it something relevant. I'm just going to call it boards. And I need to save this on my desktop. And I need to save it as a .csv. Now guys, you can get down in here and you know, come to the MS-DOS .csv. It's not going to work. There are other .csvs like the Windows comma separated. That won't work. What you need is just the straight out comma separated values .csv. Okay, so I've got a name. So I like to do it all lowercase. The name's all lowercase. That way I don't have to worry about that when I'm importing the data into R. I want to save it on my desktop because that's where I'm going to change the directory for R. And it has to be .csv. And you know, you might say, well, I'm going overboard here, making a point of this. Guys, that .csv alone, and you got something else here, it's not going to work. And I have students that have done that in the past, even though I'm going through the same old song and dance I'm going through right here. So gang, I'm going to save it. It's going to make you feel kind of silly and tell you, you know, all this stuff's not going to worry out. It is. It's going to work fine. So go continue, and then let's just get rid of it. Don't need to save it because I've already saved it. All right, so on my desktop, you'll see that I've got this .csv file called boards. Now, what I want to do in our console is I want to get my working directory. So I want to see the format that the current working directory is in. Now you should already know this if you've been watching the videos like I've asked you to, and the ones that I put up before. But if for some reason this is the first time you've seen it because it hasn't been relevant, because it hasn't pertained to a homework assignment before, here's what you have to do. Guys, what we put there has to be exactly like this. Now, there's a good chance after your name, or whoever's name of the computer is put in, there might be a backslash like documents, or I've seen a backslash. I've seen downloads. You need to replace that. After the name needs to be nothing more than desktop. All right. Now, if I hit that and nothing happens, it means it was executed correctly with no errors. If you do something incorrect, it's gonna point it out to you. Now, the next thing I want to do is I want to get my data into R. Now, this is a little confusing. The data set when it's on the desktop is called boards, right? Did I get that right? Yeah. But when the data set comes into R, it's just going to be called a generic data. I can call this supercalifragilisticexpialidocious if I want to, but I don't want to type all that. I want to keep it simple and just call it data. So I'm going to read the .csv file, and I called it boards, and it's in .csv format. Now when I hit enter, again, if it's executed correctly, you don't see any errors or any red messages. That's good. Now I'm not ready yet to do any data analysis because I have to attach the data. And the next thing that I like to do is I like to look at the names. I like to look at the variable names and see what what I've named those as. Because guys, days with a capital D and days with a lowercase d, you and I see that the same, but R doesn't. All right. So what I want to do now is I want to go back to, I want to get a split screen here so you can see what's going on. I want to go back to my problem. So what it says here is compute the means for both long boards and short boards. Now, guys, the way I do that in R is I would use what's called tapply. And I want the days across, no, I don't. I want days across type, and I want the mean. Now, I had a student one time say, Dr. Darber, how am I supposed to know that? How am I supposed to know I'm supposed to type tapply before my quantitative variable going first, my categorical variable going second, and then type mean? You're not supposed to know that. You're supposed to watch the videos and let me teach you that. Okay? So I do that, and I see that the long mean is 14.63333, and the short is 12.633. Well, it tells me right here I want to round to one decimal place. So for the long board, I'm going to put in 14.6. All right? Check my answer. Well done. The next thing, the mean for the short boards is 12.6. Check the answer. Life is good. Now, fill in the correct answer below. So, tend to go surfing more. Well, which one goes surfing more? Well, clearly the long boards, because the typical response, the average response is 14.6, which is more than 12.6. And they say statistics is hard. Guys, statistics doesn't have to be hard. It can be kind of cool. Now, compute the standard deviation for both of these. Well, guys, I want the same thing, so I'm just going to hit the up arrow. But now I change the mean to the standard deviation, which is SD. Now, let me show you what would happen if you try to make up your own stuff. Let's say you think, well, STDEV makes sense, right? Well, it doesn't make sense to R. It sees what we need and what you typed as like two different planets. But if you put SD, the command that it wants, you see that you get the standard deviation for both. So I get the standard deviation again. It come out here. It says 1 decimal place. So the standard deviation for long boards is 5.2. Check the answer. And the standard deviation for the short boards is 4.3. Now, let me show you what I have. Let's do that wrong. Let's say that we mess up and do 4.31. Now, it's going to go into making you feel like you've just completely bombed the standard deviation, but you really haven't. You just didn't follow the directions when it came to 1 decimal place. So let's go back here. Let's correct that. And you can see same answer, rounded differently. One gives you credit, one doesn't give you credit. All right, so blank tend to have more varied day surfing. Well, standard deviation measures, doesn't marry anything. It measures variation. So the type of board with the highest standard deviation has more varied days. So guys, we need to come over here and choose long. Final check. It's going to be right. Next question. All right, gang. Now, this says the birth weight are given for babies born to 22 mothers who smoked during their pregnancy and to 35 mothers who did not smoke. 7 pounds is about 3,200 grams. You probably knew that. Now, we need to click here to see our data. Now, guys, think about it. We have 22 who smoked, 35 who didn't. So we have 57 numbers that we have to type into our calculator. Or do we? Well, let's just do what we did before. Let's open an Excel. Going to give it some wacky name. Let's open it up. Now, let's learn from what we did before. First of all, let me make this larger so you guys can see it. So what are my variables? What information do we have? We have birth weights and whether or not the mother smoked. So I'm going to come over here and do like I did before, and I'm just going to call this weights, and I'm going to call this smoke. So the first numbers here, I'm going to copy those. And guys, I need that to be all no's. Alright, I want to make that look better. Now these are smoke yes, so I'm going to copy those. Well, copy them all. Now guys, this is big boy, big girl stuff here. I mean, this is literally the type of stuff that I have my students doing who are getting PhDs under me. This is just very fundamental basics things, setting up a data set correctly, but it's used at all levels. So, gang, I don't need this anymore. I don't need that first line anymore. That would just... And sometimes I like to come in, you don't have to do this, but I'm going to illustrate this here. I'm just going to come in and put an ID. And I will let this one be 1, and I just want it to number from there. So I'm going to go 1 plus the previous A2, so I can start a sequence, if you will. So I can see that I have 57 subject in this study. You don't have to do this, but I like to center things up. And now I'm going to save it. And seems like to me maybe smoke. I don't know. Seems reasonable to call this. Go to my desktop. Choose the correct .csv. And let's save it. Continue. Close it down. Don't save because we've already saved it. Now, I need to get that into R. Well, I don't need to go back and reset my working directory. All I need to do is set up a new data set. I'm not that creative, so I'm just going to call it new data. Now I need to attach it, so when I do my, well, attach allows me to focus on that data set. See, I'm done up here with boards. I don't need this anymore. I don't need days and type. I need to focus on the new data set I'm bringing into R. So I'm going to attach it. Okay. And I want to see what my variables are. So I have days and type. That's not right, is it? Oh, shoot, guys. Oh, gosh, I had a weird moment right there. I don't need to attach data. It was already attached. I need to attach new data. I would tell you that's the first mistake I've ever made, but you probably know that's not. All right, so now I've got names and new data, and you can see that I've got my IDs, 1 through, I think, 57, and weights and smoke. So let's go over here and look at what the questions want us to do. Compare the means and standard deviation in context. So the mean birth weight for babies born to non-smoking. So guys, that should tell me I need to use the t-apply. And I need the quantitative, comma, the categorical, across the mean. So the mean birth weight for non-smoking, and let's see, it says round to 2 places. So guys, this kind of stuff can drive you crazy. You saw before, if I put this into the wrong number of places, then I'm going to get the question wrong even though I got the right answer. So guys, pay attention to this. 2 decimal places. Make your life easy by paying attention, okay? So to 2 places is going to be 3584.60. 2 places. The mean birth weight for babies born to smoking mothers is 2857. 2 places would make that a 50. The mean birth weight for babies born to non-smoking, so is greater than. So now we can check the answer. It's going to be right. Fantastic. And now we go on to the standard deviations. Well, guys, what did we do with the standard deviations before? Just that. Just change SD. This finds the mean of the quantitative over the categorical. This finds the standard deviation of the quantitative over the categorical. Come down here, be consistent, 2 places. So for non-smoking mothers, we have 596.86. For smoking mothers, we have 963.17. Now, notice right here, when I round to 2 places, this next digit right there is 5 or bigger. So that's the reason I rounded this 16 up to 17. So the standard deviation for birth weights of non-smoking is smaller. And let's come in and check our answer. Now, remove the outlier of 896. Let's see. Remove the outlier of 896. Make the comparison again and comment on the effect. So guys, I'd need to go out of here. Open up smoke. And I need to find the one for 896, which is right here. And I want to delete that. and I want to save it, I'm going to save it as something else. I'm going to call it Smoke 2. All right, get rid of it. Go back to R. Now let's open up the new data. So we're going to go, I'm just going to call it new data 2. Read.csv, smoke2.csv. All right, what's going on here? Why did I not? Oh, I see what happened. Guys, let's do that again. I got sloppy there. Let's come in. Let's see. Did we wanted to remove the 896? Come in, do a save as. Call it Smoke 2 desktop CSV. Let's save it. Continue. Now it should be there. Okay, there it is. I don't really know what I did wrong before, but I did something wrong. All right, gang. So let's go back to here. It's going to work this time. We need to attach that data. And now what does it tell us? With the outlier removed, the mean babies born to smoking, so that tells me I need to do the same thing. Now I've got the same command up earlier, so I'm just going to go up and get it. Because I need the same thing, I just need it with the one value removed. So with the outlier removed, the mean for smoking is, so where are we going to? 2 places. So 2950.91. Non-smoking is 3584.60. So the mean birth weight for babies born to non-smoking is greater than. All right, with the outlier removed, the standard deviations. Guys, we need to come over here and calculate the standard deviation with the new data set. By the way, there's an easier way. I'll take that back. I don't think it's easier. There's another way to just go in and delete from the existing data set that I had up here. I may show you that later, but I think this is probably the most straightforward, is just to create a new data set. So anyway, the standard deviation for non-smoking is 896.86. As I said, 596.86. 596.86, all right? And the standard deviation for smoking mothers, 878.94. So the standard deviation of birth weight for babies born to non-smoking is less than. All right, identify the effect of removing the outlier on the standard deviation. Well, guys, let's look up here. The standard deviation for the mothers that did smoke didn't change, but by removing the outlier, the standard deviation went down. And the reason it went down is there was less variability because we removed the outlier. So we can say that by removing the outlier, we know it's going to be decrease, but now we have to come in and read the justification. Since this value is furthest from the mean, which is precisely what the standard deviation does, it kind of measures average spread around the mean, its large contribution would be removed. So guys, we need that one. and we are done. So guys, that's how you use R to work these problems on my math lab. I think a lot easier than you would on the calculator. Now let me show you one more thing. If you still you just want to do this on your calculator, let me show you one thing. What you would do, you're going to have a point where you're going to need to come in and remove the outlier. So what you would do is you would go to Edit, and you would come down to the number that you want to remove, and let's just say it tells you to remove the 17. If you'll just hit delete, it will remove that one. Then you could rerun your data or your calculations based on L2 and compare them like we did in R. You don't see many statisticians using calculators. You see a lot of statisticians these days using R and other statistical software packages. So that's the reason I wanted to create this video and show you the way I would approach that. So guys, well, I'll tell you what, one more thing. All right, let's just go back into R. Something else we run into a lot is we run into box plots. Now, if I wanted to create a box plot, for example, of weights over smoking, and that's going to be kind of cool because it's going to show us a comparison of these 878s and 596s, okay? So I could come in and run a box plot of my weights, my quantitative, over, guys, you got to use tilde. It's up on the upper left-hand part of your keyboard. For Mac, it's right above tab. For your, actually on Windows, it's right above tab too. So then I will come in and put the quantitative variable, and what it's going to do, it's going to give me a side-by-side box plot which is going to coincide with what we saw back here. Box plots don't give averages, but in a symmetric distribution, the median and the mean will be pretty comparable. So you can see that let me put this up where you can see it. You can see that for no, that the median is higher than the for yes, which coincides for what we saw for the median. I'm sorry, for the means over here. In fact, if we want to, and we could easily do this, we could just go in and take a look at the medians. So. But the important thing, or at least what I want to point out here, let's come back in and think about, let's think about this standard deviation. Notice the standard deviation was bigger for yes. And the reason is if we come to the very bottom and go all the way to the top, you can see that we have more variation in this data set than we do for the no's. When you glance at a box plot, you can get a good indication which classification, yes or no in this case, has the highest standard deviation based on the most overall spread. Now, some people like horizontal box plots. Other people like vertical box plots. So if I wanted a vertical box plot, I could come in and put horizontal equal true. And in this case, I can see that I get a horizontal box plot. Vertical is the default. So, and the cool thing about this is you could come up here and do edit copy, and it will copy this, and you could easily paste it into a document, like a Word document or a PowerPoint, or whatever you may be using for your presentation. So, gang, I think that's it. If there's anything else, I'll put it in an upcoming video. So, take care.